Welcome, everyone. If you want to get seated, we'll get started. I'll be your session chair for this session. Our first talk this afternoon will be a wrap-up of the Python Education Summit that happened here over the weekend. So with speakers Chalmer Lowe and Nicholas Tollervey, teaching Python, how hard can it be? Please give them a warm welcome. Thank you.
Excellent. For those of you who missed it, the functional Python presentation had to be canceled. So if you're here to do functional Python programming, yeah, not so much. Nonetheless, we hope that you'll enjoy what we do have to share with you. Yesterday, for those who aren't aware, we had the 4th annual Python Education Summit. We brought together educators from around the world, had a chance to sit and talk, explore techniques, tools, and things that our folks are using to educate students around the world. Looked at some of the problems we face and tried to assess ways that we might be able to address some of those things. I want to walk through a quick thanks for some of the things that happened yesterday. We'll look at a quick overview of what the day looks like so you can kind of consider whether that might be something you want to do next year. Give you some highlights from some of the talks and resources for teachers and some closing thoughts. First off, I need to say thank you to Nicholas Tollervey. He's going to be speaking here in a couple minutes, and he'll give you a snapshot of his keynote talk, which should be pretty good. I need to say thank you to all the speakers. We had a number of folks who traveled from around the world and brought their thoughts, their ideas, and their experiences in teaching to the group. And to my partners in crime, Jessica and Ria, who helped me to kind of set this thing up. And of course, Naomi Cedar. She set this up 4 years ago, got this whole train started, and I've been riding on her coattails ever since, so thank you to her too. In general, the day started off with some broad talks for the entire room. After lunch, we separated into 2 separate tracks, and then at the end of the day, we had kind of an unconference session with 2 separate tracks, and we'll walk through what each of those broke out to be. The early morning talks, there were about 3 of them, and they were focused predominantly on using games to entertain and to educate. We saw a conversation about the arcade library and how it can be used to create games in a simple and easy fashion. We had a discussion about Pygame 0, and I'll go a little bit more into that in a bit. And we looked at using Minecraft, particularly Minecraft on the Raspberry Pi, to help educate youth. And there is a resource that I'll share with you in a minute that will give you some more details on some of these things. So bear with me. This is really going to be a high-level overview. More to kind of whet your appetite and ensure that you sign up and come next year. In the second half of the day, we had separate tracks. One track was focused predominantly on pedagogy. We looked at creativity and how to drive that, particularly using graphics. The idea of computational thinking, teaching somebody a program is not simply teaching them the syntax, put a parentheses here and a parentheses there. It really is, how do you think about a problem? How do you decompose it into subsets? And how do you solve those individual problems to create a whole? We looked at how the Montessori method and some of the techniques that are used in there might be beneficial for teachers. We saw some data analysis on failed attempts at a simple programming project like Hello World. And what does that mean for us when we're teaching programming? And what does that mean for us in conversations with the developers of the language, etc.? And I'll talk a little bit more about the failed attempts in a bit. We had some conversations on general tips for teachers. We also had a separate session focused on doing data science, right? Data science is the buzzword of probably the past 5 years. How do you teach folks at the collegiate level? How do you teach folks in businesses and in industry how to do data science? So we had some conversations about math. We had conversations about what it is like to teach a scientist, and how is that different than teaching like a 5th grader? Hint, it's harder. Teaching data structures, and what does that mean, and why is that important? How do you get into coding as a career, especially in places where coding may not be prevalent as a career field, or maybe there are disadvantages in front of you that you have to overcome? And we looked at ways to simplify data science lessons plans. For the unconference session, we asked the folks in the audience to come up with ideas of things they wanted to get together as groups to discuss. And we had about 7 or 8 different ideas. Everybody got a chance to vote for their top 2 favorite ideas. And the ideas that came out of it were, let's have a good conversation on techniques and methodologies for building curriculum. And then we had a separate conversation about what do you do for those in-betweeners? In-betweeners meaning they're no longer a beginner, but they're also not a developer per se, right? They're somewhere in that middle ground. What are techniques for those folks? How do we take them to the next level and get them on the track to becoming a solid developer? Some of the highlights, and before I walk through what's on the slide, I want to point out the link at the bottom. This link is on the next 4 slides, so if I move to the next slide, don't worry, it's still going to be there. This is a shortened URL to a Google Doc. And what we asked the audience to do as we went through this thing was, as you have thoughts, as you have ideas, as you see something that somebody says, please put down a few notes or thoughts or ideas about that in this Google Doc. And it's open and available to anyone to view. So if you wanted to go see kind of what the thoughts were as we were having these conversations, you can go. It is completely uncurated. It is completely unedited. So you're going to see really bizarre things like, I don't even know what that means. But there's also a lot of good snippets and tidbits in there. There's URLs to learning resources. There are ideas and thoughts that people thought were pertinent that the speakers shared. So some of the highlights. There's a big push from our friends in the UK on this idea of building programming tools that have a very, very simple interface that children can use readily and easily, logically. 3 main efforts that came out of this were Pygame 0, GPIO 0, and Network 0. These are all designed for youth. Some of the folks who developed them are in here in the audience. I know Daniel's in the room. These things have very simple syntax, so kids can sit down and know what they're doing when they type the command because it's written in language that they get, right? We had conversations about using Raspberry Pi as this intro vehicle into low-cost programming education, and you're going to see something that goes even a step further beyond that when Nicholas comes up and talks. We talked about how we can take our students and present them with real-life coding opportunities, get them engaged in open-source projects. So instead of just banging out some code that they found in a book and going, ooh, wow, it worked, they can interface with people on real live projects and have some sort of a repertoire of projects they can point back at proudly. We looked at some of the benefits of teaching low-level languages and high-level languages at the same time, so the youth can kind of see things from different perspectives. We looked at the importance of errors and the detrimental effect of errors. So errors teach us something, right? If you don't make mistakes, you're not going to learn because you're not going to think. But one of the things that we find is as students run into errors, if the errors are not inherently clear as to what the problem is, they will sometimes become so put off by that they just give up. A lot of this comes from some of that, the assessment of that hello world problem. It's one of the simplest things that you can possibly do, yet a student comes in and it fails. And they get so put off because they don't know what's going on that they just don't come back. We looked at some tools that folks have created. There's a virtual machine out here called Merlin. It's created by Dark Labs to help data scientists teach data science to students without getting into all of the crazy. We looked at the importance of collaborating outside your normal networks. One of the things that we see is, when we are in our own little echo chamber, it's really, really hard for us to kind of look outside of those boundaries and see where the weaknesses and problems lie. Just listening to some of the things they've been doing in the UK and comparing that to some of the things that folks are doing here in the US, I got to see a lot of really good opportunities that I want to take advantage of for teaching. We got to see some fun things, the Ozobots and what you can do with those. All right. In terms of resources for teachers that I want folks in the room to know about, Python maintains 2 education-focused working groups or mailing lists. We have the EduSig, and if you Google EduSig info, we also have Python edu.-wg. If you Google that and the word info, you'll be taken to the Python page where you can sign up for both of these mailing lists. The difference between the 2 of them, EduSig is more about conversations on education. Hey, I learned this thing. This was cool. I had trouble with this. The working group is intended to be a collaborative environment where folks are working on particular problems. Right now, 3 of the problems that we're heavily looking at are education-friendly editors. IDLE may not be that thing, so how do we get to the next generation of IDLE? Lessons and resources, and how do we as a community help drive the best of the best lessons and resources? And then how do we improve our internal communication, coordination, and facilitation? We do have a Python Slack channel that folks can get into and have kind of a more real-time conversation. If you want to be invited to that, unfortunately, you just can't sign up for it. If you want to be invited, hit me up on Twitter at Chalmer_low or my Gmail account. And throughout this event, as you come across something that might be of interest to your fellow educators, please tweet that out, send a URL, etc., at #PyConEDU. With that, I'm going to turn the time over. Oh, wait, one last thing. I'll come back to this when he's done. Go.
Okay. Good afternoon. Okay, so I'm just going to change these slides over.
Yeah, you can kill the slides.
Right. Why is that not dying? Okay, so my name's Nicholas. As you can probably tell from my accent, I'm from the UK. I'm just looking over here to see whether they changed the font. Teaching Python, how hard can it be? I'm going to tell you the story of the BBC Microbit, which is just being launched and rolled out into schools in the UK at the moment. Could you just put your hands up if you've heard of the Microbit before? Okay, that's about half of you, I reckon. What is BBC Microbit? Well, this little video should explain what the intention of the project is.
In the future, hover shoes, flip button, hologram of your nan comes up.
It shows you like a map in front of you.
Inside the fabric is Wi-Fi.
Wi-Fi. Yes.
Yes. Oh, yeah.
Oh, that gives me an idea. You know with shoes?
Trampoline shoes that would hover.
That is rubbish.
So, yes, 1 million of these remarkable devices are going to be given to all of the UK's 11-year-olds, and we're about 3/4 of the way through, so 750,000 of these devices have been delivered. The BBC has form in this. This is my first computer. It's a BBC Micro, and in the 1980s, every school got one. My father was a head teacher, and it took me about half an hour to pry it from his hands before I could get a go on it. And this is what it looked like when you switched it on. It made a strange bleeping noise, and then you were presented with this. And after a few months, I kind of figured out that you could make this thing do something. So I remember my first computer program. It was in BBC Basic, and it went like this. 10, CLS, which means clear screen. 20, print, in quotes, Andrew is an idiot. 30, go to line 20. And then Andrew is an idiot was all over the screen. Andrew is my long-suffering younger brother, who is an exceptionally talented musician and coder at the same time. So I like to believe that I didn't cause too much harm there. The important thing is that I realized in that moment that I could get computers to do really, really cool things if only I learned what the special incantation was. And this is the purpose of the BBC Microbit, is that we recreate that sense of wonder and that sense of, I can make this thing do funky things. So about 18 months ago, the BBC said that they would be doing this project. They mentioned that Python might be part of this. I'm a PSF fellow, so I wrote to the board and I said, hey, the PSF should be involved in this. And they said, okay, apply for it. And, well, the fools, they said, yes, come and join this partnership. And so, to cut a long story short, I had to work with Damien George, who is the creator of MicroPython. If you don't know what MicroPython is, Damien has single-handedly re-implemented Python 3 for microcontrollers. Now, if that weren't enough of an incredible achievement, he's actually a physicist, and this is kind of fun for him. So MicroPython is a remarkable achievement. Why would we want to do this? Because all of the work that's been done from the Python community in the UK has been done by volunteers. Well, I was discussing this with some people last year. Why on earth would you want to do something like this? Well, this is the answer that I gave to them. Asking what sort of education and learning our community supports is how we decide what sort of community we will become. For it is through education and learning that we engage with our future colleagues, friends, and supporters. And this is all about making the Python community sustainable, the community that was discussed in the keynote this morning. So, without further ado, we better have a demo, hadn't we? So just bear with me while I faff about here. So the problem with a microbit is kind of in the name. If I hold this up, it's small. So how are we going to get around this? Just bear with me. Cheese. Oh, awesome. This is a BBC microbit. It's about the size of a credit card. On the front is a 5x5 LED matrix, so you can make it display pictures and scroll text. It has 2 buttons that you can press, and across the bottom are GPIO pins, okay? Some of which are big enough for you to be able to attach things like this crocodile clip here, or alligator clip, whatever you call it in the US, I don't know. And on the back, the different parts are labeled. We have an accelerometer, a compass, there's a Bluetooth antenna here, a reset button, you can put a battery in here, so you can, currently the device is just drawing power via USB, but that's how you program the device as well. It appears as a USB device, and you flash Python scripts onto it. So I'm going to show you, I'm going to give you a quick demo of how that works. If I can remember which way around my screens are. So this is an editor that I wrote for children. It's based on the feedback we got from the Raspberry Pi Foundation. And they basically said, just let children write code. And if you look at the bottom here, I hope you can see. In fact, one of the features is zoom in. So why don't we try that? So people at the back can see it. So at the bottom, you'll be able to see a Python prompt. This is Python running on the microbit, okay? This isn't my local Python, this is Python on this remarkable little device. So I can do things like print, hello world. I can't believe I'm doing live coding in a talk. There we go, hello world. This is the sort of thing you might want to do, but I can also do display.scroll, hello world. Okay, and I need to be quick here. There we go. And this is, again, you can make this thing say whatever you want. It's that kind of, you know, it's a recreation of that moment that I had all those years ago when I was rather rude to my younger brother. So what else can you do with the microbit? Well, you can make it display images and things like that, so it's quite visual. But the favorite thing is when you can actually plug things in. So UK people will smile at this. Here's one I prepared earlier. This is a very cheap speaker. And if I plug this into the microbit, I will prove to you that it will play music for you. There we go. And all I need to do is import music. That's a bit obvious. So if I do a dir of music, what have we got here? We've got several methods, and we've also got some built-in melodies. There is also a way that you can specify your own melodies as well. There's a very simple musical DSL in there as well. Thank you. So let's see if we can get it to play a tune. I'm sure you'll all be able to hear it at the back. Let's see if that helps as well. So music.play, so it's nice and obvious. Music. Somebody suggest a tune. Da-da-da-dum, okay. What do you think it's going to be? Da-da-da-dum. Let's see, I'm going to stand close, so. Okay, so now that's kind of fun, but we can also get the microbit to just play pitches like this. So I'm actually a classically trained musician, and when you tune an orchestra, the oboe plays an A at 440 cycles a second, so this is an A. And then, you know, the orchestra will start to tune up. But I can start to do other interesting things like this. So, while true, so I'm going to put it into an infinite loop. I want it to play. And I need an integer. Now, where can I get an integer from? Well, there's an accelerometer built in. So why don't we get the X reading from the accelerometer and play it for 20 milliseconds. Have I got the things right? Yes, I have. So, Now, just imagine a room of 30 teenagers on a Friday afternoon. Teachers are going to love this. The important thing is that we try and make it very easy for children to be able to explore and experiment. We want kids to be fearless in making mistakes and making really weird things with this remarkable device. We've put Easter eggs into the implementation of Python. So if I import this, we don't have the Zen of Python, we have the Zen of MicroPython, which obviously is a lot smaller. I've suddenly realized, though, that the rhyming couplet at the end, be brave, break things, learn and have fun, express yourself with MicroPython, doesn't work if you're American, because it's MicroPython. Imports, anti-gravity. So that was implemented by a couple of 16-year-olds. We've had an 11-year-old girl contribute some of the pictures, the images that are built in. And like I said, these devices, we're about 3/4 of the way through giving 1 million of these out. It's not just Python that runs on these devices. Microsoft, and I need to mention there are other partners involved in this that provide programming solutions. But that, in effect, is a thumbnail sketch in about 5 minutes of what the microbit is. We may have time for questions. Yes, we may have time for questions. So, if you have questions, ask a question.
Wait, before we do the questions, that last slide that I had was, if you want to be involved, let us know. We'll try and see how we can get you involved. If you think this is of interest to you and you want to attend the Education Summit next year, let the staff of PyCon know. We were limited in the number of seats that we had this time around, so we had to turn folks away at the door, as it were. We were limited in the amount of space that we had. We did not have video coverage, so we couldn't record the talks. If the staff know that this is important to you as educators, let them know and see if we can find ways to improve our ability to serve the educators in the Python community. And with that, we'll do questions.
Yeah. Any questions?
A couple of minutes for questions, if you want to step up to the microphone here.
Is this cross-compiling only, or do you actually have a chance to put a keyboard and monitor on the device so it can be independent?
So, no. The way you use the device is you plug it into a computer and then you use it via the computer. Interestingly, when you try and do that with a Raspberry Pi, a lot of kids find a problem trying to source a keyboard and a monitor and so on and so forth. So it was designed just to stand on its own. The only thing you need is another computer to work with. Yeah.
Hi, my name's Jerry. Just on this Saturday, I was asked to give a talk to a bunch of 5th graders coming up in a month or two. So do you guys have resources for someone like me who's shy by nature to be able to get in a bunch of 5th graders and talk to?
If you ask me afterwards, I'll point you in the right direction with some resources for you, videos and such like.
Thank you.
You're welcome.
So is this device, is it available in America yet? And then what's the price
Okay.
that you guys are aiming for?
Yeah. Where can I get one is essentially what you want to know. Okay.
Forget children, I want it, me.
So they won't be available until the rollout to the children has finished, which will be mid-June, I believe, so not very long. They will be sold by Farnell online. So you just order them like you would do a Raspberry Pi via mail order. There will be certain shops that will supply them for you. How much do they cost? I can't give you precise details, I'm afraid, but it would be pocket money range because these are devices aimed at children. It's important to note that all the resources that you need to recreate both the software and the hardware for this device will be open source, so other countries will be able to recreate this project. So we know there are other countries, quite a number of other countries, if I read the messages from the BBC properly, who would like to recreate this.
The next question will be the last one.
Thank you.
I was just curious about it seems like, you said you can flash scripts onto the device, but it seems like there's also this interactive mode.
Yeah.
How do this, what are the constraints for scripts that are flashed onto the device and then running on their own? Like, for example, Arduino has a setup and loop, and that's kind of it. Is it sort of the same thing, or?
So you have 16K of RAM. So you need to obviously work within that constraint. There is obviously a battery connector, so it will run autonomously from a PC. It has a small file system, which Mark Shannon finished about 3 weeks ago. And I've just finished building a tool that will allow you to interact with that, so you'll be able to get data on and off the device. It's up to you to program a loop and things like that, but we made that explicit because we want children to understand that this is kind of how computers work, rather than some hand-wavy magic.
Awesome, thank you.
You're welcome.
Thank you very much. Let's thank the speakers again.